Hey guys, welcome back to another episode of the Real Hacker Hours podcast. Today I'm going to be continuing work on my Ghidra script for static bug fighting, and right now I'm going to be writing a check for strcpy. Now let me go ahead and write a test case so I can better show what I excuse me, better show what I'm exactly searching for. I'm going to go ahead and just copy this test case. And let's go ahead and remove that and change this make file. It's going to just take a second. And let's go ahead and edit this so we can have strcpy, so we scan it in. And then we have our strcpy call. So the first and obvious choice that we're going to have is going to be checking for something like this, where we are writing in a variable amount into a fixed size stack buffer. So how can we check this? We will have to check both the destination and the source. For the destination, that we can just use the, where's the function? I think it's get var size, maybe get destination size, get stack var size, since this function should, with the POCs that we've done, return -1 if it's a register, and if it's a stack buffer, it returns the size of it. This should be able to tell us if it is a stack buffer or not. And for input, that's going to be a bit more tricky because effectively what we're checking for is this a static string or not? So if it's something like, here, let me put it. If it's something like this, where it's a constant value being written. So how can we check for that? Well, we just made the sprintf check, which will be able to effectively get the format string from a particular argument. So perhaps we could write some additional functionality that will effectively just check which one it is, but let's start working on this. So let's go ahead and compile this, and let's go ahead and run this. File next test, basic strcpy, strcpy 00, let's copy that here. Run headless analyzer against it first. I'm going to go ahead and add the strcpy check. Func stop. Put strcpy 5. And after I get done with this check, I should have a pretty good idea of how I want the check structured. So I'll go ahead and clean up the code, which I should have done already. Case 5, analyze strcpy, function to analyze the reference, and then we break. Next we have public void analyze strcpy, function to analyze, and then reference ref. And then we're going to have our check, and what are we going to call this check? It is going to be public void string write to stack. Wait, no, that's not. Strcpy to stack. Oh, variable string copy to stack. I feel like that's the best. For this, what we'll need, of course, the function that we are analyzing. In this case, will be strcpy, the reference to the call, and then we're going to need two different arguments, the destination argument and the source argument. And just going to go ahead and copy this code here. And okay, so when you get to here, that will be where we actually end up with the P code that we want, which is the P code that actually is responsible for the strcpy call we're looking at. And let's get the destination var node. And then there's a source var node. Source arg +1. Okay, cool. So we have the destination and the source var node. For the destination, that's going to be pretty simple. We just use the function, where is it? That like get stack var size function. That should tell us if it is a stack or register value based upon what we've seen so far. Now, one thing I will do after I get like the first POC test cases done is I will go out and like use this tool against a bunch of different code bases that like I didn't write, and by using against those, they'll effectively test and make sure that there aren't problems that I'm overlooking here. Now, what's next? Give varner defl. No. Oh yeah, back to here. So the source var node, that's primarily what's going to be causing us problems. So for this, what I'm going to do is I'm going to make two different test cases, one with a variable source and one with a string source, and I'm going to look at the definition P codes for those two var nodes, compare them, and see if I can think of how to do it from there. So let's go ahead and just copy this test case. And let's go ahead and replace this with a string, or I should say a static constant string. So that's that. Did I? Yep. Fix the makefile, we compile it. Might, yeah, never mind. Okay, cool. So we're looking at this, and let's go ahead and copy strcpy here. Let's make sure that that runs. Nope, I made a mistake on line 69. So let's go ahead and run it now. Oh, I already imported it. Need to change it from attack import to attack process. Cannot find simple. Get var node def file line 375. What is going on here? Oh, remnants. I didn't fully get rid of the previous check code. So this one should run. Okay, that looks like it's running just fine. Let's go ahead and print the source var node. Source var node. And then let's print the definition for it. And let's add this check to strcpy. Reference. First one is destination. That's going to be 0 and 1. Let's go ahead and run it now. That did nothing. Something is not working. Let's see. Is the analyst strcpy function being ran? Actually, let's just first check. I don't think it has strcpy enabled. Okay, so it looks like in strcpy 001, since strcpy was writing a constant value that it was never going to be changed, the compiler just did an optimization, just left it out. I checked for it via just looking at like the global offset table for 000. You can see that strcpy is right here, whereas for 001 we tried and it's not present. And here we see that the definition here is pointer sub. I just thought of a potential way that we could do this. And let me well, not 100% sure yet if that is the correct way we should do this, but so actually what's the first problem here is that we have a test case that's the strcpy is getting optimized out of it or inline or something like that, and we need it so that it is a constant. How can we do that? I'm gonna pause it while I think. Okay, I was able to get strcpy actually compiled into it and not just inlined or optimized away. Did this via establishing a constant char pointer that is the source. So, but then, or would it be the same because it's. I'm gonna pause it again while I think for a second about a potential problem. Okay, so for now, I'm gonna leave strcpy 01 as is, and let's see what the definitions in the var nodes look like here. Going to have to re-import it, and I'm going to do a different project so I don't have to get rid of the old project and deal with that. So we see here it's a copy from a constant. I'm going to open it in Ghidra. Actually, no, I'm not going to run it in GDB. I'm just going to check in Ghidra. Oh wait, I already have Ghidra open. What am I doing? Let's go ahead and close this. Let's throw strcpy in. analyze it. Okay, here it is saying it's getting copied from this address. Let's see what's here. Okay, cool. So we're seeing here that the definition of the var node, which this is the var node for the source, this is the var node for the definition. You see that it has a constant argument, which is the address of the string, so that's a good thing. It's similar to what we saw with sprintf. And we'll look at just 0, 0, 0, which this has a variable, right? You see that the constant value is a stack offset. So what do both definitions have in similar? The constant value associated with that P code is effectively the value that we're looking for. And what I think we might be able to do is we might be able to call get stack var size on this var node. And thing is about this, what this will do, of course, for the one that's a stack or it's a variable, it should, actually this won't work. It'd probably be better, yeah, reason for that being is if the definition was a, what do you call it? A stack buffer, that would work just fine. And if it was an offset to a string like we're seeing here, it would be a positive value, so that would mean with the code it would return a -1, so that would work. However, there is a third case that's probably going to be pretty common, and that's where the source is coming from, like a malloc or a function argument, in which case that will probably be a little bit different, probably be from register. So what I'm thinking is probably the best route, at least as an initial POC step, is to try and get an actual string from the strcpy, and if we can't, then assume it's a variable, right? That's what I'm going to try now. Now, even if I get it working here, it might not work for a lot of use cases. That's a part of why after this I'm going to be doing a lot of vigorous testing to hopefully hammer out those potential issues. But for now, I think that'd be the best case scenario. So how will we do this? We have the source for our node, and we can go ahead and this will get the offset, and then next I need data address. I'm going to see if this is going to be null for the instance of the stack buffer. Data address. Let's see what happens. It could crash, it could not. Oh, I'm importing it. Need to process it instead. Can I find some format var node? It should be source var node. Okay, so this is a bit interesting. We got the offset and it got the address, but it doesn't. We definitely did get the address since source is print and the source var node is printed here, definition var node is printed here. And it's taking the actual stack offset and turning that into an address, which is a bit interesting, but that won't work for us. Let's see what it does for the instance where it is an actual static string. Okay. Now, what we might have to do is we might actually have to try and get some data from it. So let's try system.out.println format string. Cannot find symbol. Oh, I misspelled this. Okay, that it was able to get us the string, which expected. Let's see what happens when we run against strcpy 000. So this has the variable source. It breaks. Okay. 192, 376. So it breaks and gets string at. F x is equal to null. Return. Let's see if that fixed the problem. Okay, it appears that it did. So issue was it was trying to get the data at this address here. Of course there's no data there, so the data returned null, so it got a crash. So what we can do is get string at. We can do a check here if this should be source string is the mumbling. If it does not equal to this, return, because if it can't get the string, that means that the source is static. And let's go ahead and change that. So that should do it. Also, another additional thing that we can do is we could potentially get like the min and the max address of the binary and compare that to the address that we're getting of the string. The reason why I say that is if it is a static string, it should have an address that is somewhere within the binary segment, so that should be another check that we can do. Now for that, I think what the best route would be, current program, look at the Ghidra API docs for current program. Current program, what is current program? It is this type, get max address and get min address. So we can do current program dot get min address and get max address. I want to quickly go ahead and see what this does. Well, what the values this gives us. Dot print line current program dot get min address and get max address. Let's go ahead and see what addresses this gives us and compare it to the actual min and max addresses in Ghidra. Format string, this should be source string. So we see that the min address is this right here, which when we compare it, that this is indeed the minimum address. Cool. However, Stop. Wonder what it would give us for the offset for this. The max address is giving us the elf section headers 0x7bf, which we're more looking for like this address right here, 105047. So I wonder what happened if we wait, can we do current, does it have like a dot contains address? Or dot has address A B C D E F G H. Get register, get program user data, get min address, get what is an address factory? Don't think that's gonna help me. Let's go ahead and try running this. Oh wait, this is gonna crash. Forgot a period instead of a not semicolon, a comma. 1983. Yeah, this is gonna, so what are we gonna need to do? We are going to need to somehow determine if this address is indeed get stack space, get register. No, I'm just gonna Google Ghidra has or contains address. Does it have a function like has address maybe? No. Is valid address. Okay, we might be able to do this. So current program.get address factory. And we might be able to use the is valid address. So let's try that. System.out.println current program.get address factory is valid address. And what address are we dealing with? We are dealing with data address. This should return false. Turns true, probably because the address that's being passed was constructed or something like that. Get address spaces. What we might have to do is, okay, what I think we're gonna have to do is iterate through the, looking at this address factory here, we can get address spaces, which will return an array of all the address space, and we could iterate through that potentially. I'm gonna go ahead and try that real quick. For address space sp in current program dot get address factory dot get address spaces. We're going to print out the sp dot get min address system and the max address. Now, what I might want to do is, if this turns out being the way I want to do it, as a part of the initialization, just go through, loop through these, and like make some sort of easy data structure that I could just parse later on. That way, just make it easy on myself. And address space. Did I make a typo? No, cannot find symbol. I think I imported this. Yeah. Wait, do I need to do this as well? Import address space. Is that the issue? Okay, that was a bit weird. I'm not sure why it has an address space from 0 to 0xFFFF. Okay, well, for now, what I'm going to do is, since this video is 30 minutes long, I'm going to put the address resolution or figuring out exact address space of the binary stuff for later. Right now, we have a method that works for the 2 test cases that we have so far, and if we probably will need to do a bit more work on it, but oh well, we have a good first step. And also I'm going to just throw in the extra check here to make sure that it is a stack. Stack buffer for the destination. And for that we can just do so this checks if it verifies that the source is variable. This checks and verifies that the destination is, what do you call it, a stack buffer, and if that happens, we can do the report function to analyze, reference in the enum var strcpy stack, and I'm going to have to change the other call I did. So let's go ahead and change this, and let's go ahead and add the enum, private static final integer var strcpy stack equals 5 var strcpy stack. Okay, that should do it. And let's go ahead and copy this. Okay, let's try running this. This should flag it. Did not get a flag, cannot find symbol. 3.3. Oh. Destination. var node. Okay. This should be it. Okay, that got flagged. This should not get flagged. And while that runs, I'm just going to make one more test case and just see what happens. This is going to be if the source is a malloc trunk. We see here that it did not get flagged, so that operated the way we wanted it to. So let's go ahead and just make this last test case and see what happens. So input. Target. going to make a mallet chunk. Just call this M for now. M equals malloc 100, and just throw that in there. Actually, what we can do is let's undo that. Let's make input the char pointer. Okay, yeah, the source is still a variable, but it's from a malloc, which might throw it off. I'm not sure. Let's see. Oh, this needs to be input. Also, I think I just made just realized a mistake where for the fgets, the destination was the target. Object dump. Forgot string dot h. Okay, let's make sure that it has all the functions that we want it to have. Has strcpy, has malloc. Okay, let's throw it against the tool. Let's see what happens. Basics strcpy 02. I import. Okay, it's running. Let's see what happens. And it flagged it, which it should have. So that's good here. One last thing I'm going to just check quickly. Strcpy. Okay, yeah, this is a mistake. It should be input that's a destination for fgets, not target. Yeah, that was a complete mistake. Okay, good. And also, let's just go ahead and add this to it while we're at it. Okay, cool. So I'm going to cut off this episode here. Thank you, gamers, for watching.